Hey guys, today we're going to be talking about regular or platonic solids. You could use either adjective if you wanted to. Now, in order to talk about platonic solids, it helps to understand what a regular polygon is. And so, you probably already know what a regular polygon is. You have this 2D polygon, right? It's all filled in, the edges have to be straight, and all of the interior angles have to be the same, and all of the sides have to be the same length. If you don't meet this full checklist, you don't get to be a regular polygon. So a square is a regular polygon, right? You got all four sides the same, you got four 90-degree angles, definitely a regular polygon. And a rectangle that's not a square is definitely not regular because the sides aren't all the same length. But check it out. Have you ever heard of a rhombus? All four sides are the same length, but it's got two acute angles and two obtuse angles, and so this isn't a regular polygon either. So be careful to note that if your polygon is going to be regular, it has to meet both conditions about angles and sides. So what about the 3D case? If you've got this polygonal solid, right, it's all filled in just like a die, that solid is platonic or regular if all the faces are the same regular polygon, right? Only one regular polygon all around, and the same number of faces meet at every single vertex. So below, I posted a link to some Wolfram demonstrations about the regular solids. There's 5 that we're going to be studying. And in this demonstration, it's pretty simple, but you can grab it and you can rotate it. You can alter the transparency so that you can see it as if you would see it in the real world, or if you want to, you can make sure to see all of the edges at the same time. And so here, this is the first platonic solid, is the tetrahedron. It's made out of 4 different equilateral triangles, and it's got all of the properties listed out here: 4 faces, 6 edges, and 4 vertices. And you can see how, if I look at it from, say, the top down, at every single vertex, no matter what, 3 triangles are coming together at every single vertex. So that's the tetrahedron. By contrast, if you take a look at the icosahedron, we'll turn down the transparency here. This guy is made out of 20 different equilateral triangles, and at every single vertex, you've got 5 of those triangles coming together. And so that's why this makes a different regular solid, even though it is also made out of equilateral triangles. And finally, the octahedron, also made out of equilateral triangles, but check it out. 4 triangles are coming together at every single vertex, and it's going to result in a completely different shape. So you can use these demonstrations as a beginning attempt to understand what all the little properties of these 5 regular solids are.